All right, ladies and gentlemen, so today we're going to do chapter 2.2, which is just basic differentiation rules. Okay, today we're going to show you the constant and the power rule to find the derivative of f of x. That's the little f with a little tick mark on top. That means the derivative of f of x. And we should know derivative is what again? What's derivative stand for? Slope. We're finding the average rate of change, the slope of the function. So first things first, the constant rule is super easy. Okay, says if f of x is equal to any constant, then the derivative, the slope, is 0. Well, that should make sense to you if you understand what a constant is. Okay, so for example, let's take f of x equals 5. Or you guys are used to seeing it y equals 5. Do you guys know what that is a graph of? What is the graph y equals 5? It's a horizontal line. Very good. 1, 2, 3, 4, 5. That is a horizontal line at y equals 5. Now, remember, you guys just said derivative is slope. Well, what's the slope of any horizontal line? 0, right? Horizontal has 0 slope. It's 1 to say. Well, the derivative of any constant is 0 because that's the slope of that horizontal line. Okay? So hopefully that makes sense. Any questions, y'all? Now, we just painstakingly went through the definition of the derivative and found the derivative of all these functions. Well, now we're going to show you the power rule. Anytime we have a polynomial, we're going to take the power, the exponent, okay? We're going to take this guy, and we're going to drop it down and multiply it to anything in front, and then we're going to subtract 1 from it, okay? All right, so as I take a look, I have y equals 4 is example number 1. I have a constant. What is y prime? What's its slope? 0. Done. That was easy. I take a look at the next one. I have f of x equals 2x plus 5. Okay, my final answer, I'm going to get the derivative of f of x. Okay. First thing I'm going to do is do a little work here. Think of this as 2x to the first. If you're using the power rule, this is kind of like the idea. You're going to bring this power down and multiply. So power comes down. I have 1 times 2 is 2. And then I subtract 1 to the top. So 1 minus 1 is 0. Okay. Well, what is x to the 0 power? That's 1. And then 2 times 1 is 2. And then we move to the 5. What's the derivative of 5? The derivative of any constant. Derivative of any constant is 0. So we end up with 2 times 1 plus 0 is just 2. Okay? Now, I never ever do that work. I'm just doing that for you guys so you can see the power rule in action. I would go right to this step. Now, I hope this makes sense because as we take a look, what is this a graph of? F of x or y equals 2x plus 5. That is a line. And what's the slope of that line? What's m? My slope is 2. Well, what's my derivative? 2, right? Okay. I would not be doing any of that work there. Normally, I go right from this step to that step. Okay? All right. Any questions on 1 or 2? Yes, sir. What's that? The derivative of any constant is 0. That's a constant. So when you have a polynomial, you kind of look at each one individually, and then you do that one, and then you simplify. Okay? So good question. So let's take a look at example number 3. As I take a look, I've got f of x equals x squared minus 1. And I want to do the derivative. So as we take a look, I take this exponent and bring it down. So I have 2 times x, and then I subtract 1 to the top. So that's 2x to the first, or 2x. And then ramen, I have -1. What's the derivative of -1? 0. So 2x to the first plus 0 is just 2x. And I'm done. Okay? Yesterday, or I should say Friday, we did one just like that. We did the derivative of f of x using the definition of the derivative. Oh my gosh, look at all this work we did. And we got 2x. Okay? We're doing the same thing, but in like 2 seconds. Isn't that a beautiful thing? Oh man. Any questions? So what they started doing is they started doing that definition of the derivative, and they said, hey, there's a pattern here. Oh, with polynomials, all we got to do is take that exponent, bring it down, and then subtract 1 from it. That's all they saw. And it worked every single time. So they said, hey, throw this definition of the derivative out. We don't need to do that anymore. Let's do this thing, and we're going to call it the power rule. Okay? Because we're going to take this power and drop it like it's hot. Bring it down. So I've got the derivative of f of x. And what's the derivative of x squared? Just 2x. And then what's the derivative of 4x? Just 4. There we go. Again, crazy thing. We go back to our notes from yesterday or Friday. We did f of x equals x squared plus 4x. We did all this work. We got the same answer. Right? Don't really need to do that work anymore, do you? We know the power rule. Any questions on how I got 2x plus 4? All right, so let's put this into action. Number 5. I got the derivative of f of x. I'll do this one in blue. What is the derivative of 5x cubed, y'all? 3 times 5 is 15, x squared. Very good. I do the next one. I got 7x squared. Hayden, what do you got for that one? Don't forget to multiply these two. Yeah, 14x. Boom. Just take the 2 times 7 is 14 and then remove one of the exponents. Awesome. Who's got this one? Who's got the derivative of 6x? Just 6, yeah. And then what's the derivative of any constant? 0. Don't need that one. Okay. So if we have a degree 3, largest exponent of the function is degree 3, then we're going to have a degree 2 for the derivative. Okay. Eventually we would talk about, hey, what's the second derivative? Okay. That would be taking the derivative of the derivative. Yeah. And you would get, the next one would be what, 30x plus 14? Okay. And it's always reduced one exponent. Okay. You guys have any questions with 1 through 5? So when you take a look at 6, oh my gosh, as I take a look, where's the x at? It's in the denominator. So this is technically not a polynomial. These guys are polynomials, okay? Where the x's are in the numerator or on top. This is technically a rational function. So we got to do one of two things. We either got to get the x back up top, or we got to learn the quotient rule. Okay, do you guys want to learn the quotient rule right now? No? Yeah, let's just stick to the power rule today, okay? So we need to do a little work here. So the first thing is I'm going to go ahead and simplify. I'm going to square this 3x. So 3 squared is 9, and then x squared is x squared. Okay? Now the last step before we take the derivative is we need to get this guy out of the denominator and move it up top. So we talk about uptown and downtown. It's been a while since we've done this. You guys remember uptown and downtown, moving from a denominator to a numerator or vice versa? Remember what we have to do? Any guesses? Yeah, we had Duncan says negative exponent. So if it's downtown, we can move it uptown. So we can make this 1/9 and then x to the negative second. Duncan said negative exponents. Same thing, if you ever have a negative exponent that's uptown, you can shoot that downtown by making it a positive exponent. Okay, so I have not done the derivative. That's why I rewrote it. It's just f of x equals 1/9 x to the negative second. Now I can do the derivative. Okay, so now I can go ahead and bring this guy down and multiply. So I'm going to take negative 2 times 1/9. What's negative 2 times 1/9? Negative 2 times 1/9. What's negative 2 times 1? Negative 2 and then over 9. And then I subtract 1. Well, what's negative 2 minus 1? Negative 3. Now, I don't love that. I would probably accept this because it's the end of the year and you guys are about done. But my math lab is not going to accept this. So last thing we probably want you to do is have positive exponents. So if it's uptown and it's negative, we need to shoot it back down. So we need to take this whole guy and put it down with the 9. So final answer I would have for my math lab would be negative 2 over 9x cubed. And that's probably what my math lab is looking for. Okay. So again, rewrite it, bring your x to the numerator so you can do the power rule. And then once you do the power rule, you might have to send it back downtown. Okay. Eventually, we're going to show you the quotient rule tomorrow. Low D high minus high D low over low low, but we're not ready for that yet. Let's get through the power rule first. Okay. You guys have any questions with 6? Would you like to see another made-up example of that? Yes or no? No? Yes? Thumbs down on seeing another example? Yeah? All right. If we have time, we can go over like number 9 on your homework. How's that? We should have time, right? We got 11 minutes. Let's giddy up. We got derivatives of 2 trig functions that we should know. So the way you read this, guys, is the derivative of sine of x, and this is over dx. That means with respect to x. So we're going to take the derivative of sine of x with respect to x, and that's cosine. And this reads the derivative of cosine of x with respect to x is negative sine of x. So that's just 2 little rules you got to know. The derivative of sine is cosine. The derivative of cosine is negative sine. That's all. Okay? So they're going to maybe mix those in on the worksheet. So as we take a look, I've got f of x equals x cubed plus 4 times the sine of x. And we're ready to do the derivative. So first thing is just kind of cover up this guy and do the derivative of x cubed. So bring that exponent down and deduct 1. What do you get? 3x squared. That's easy. And then I have plus 4 sine of x. Well, we got 4. And then what's the derivative of sine of x? Cosine of x. So that's how we got that part. And then that's it. So it's basically doing the power rule, and then just remember what the derivative of sine of x is. It's cosine. Any questions, y'all? So as I take a look at the next one, do you see the problem with 1 over x? Right? X is in the denominator. We got to bring it uptown. We got to do Duncan's little trick. My main man, Duncan, says bring that guy up to make that x to the negative first. Okay, everybody all right with that? So basically, I only did was I rewrote that first 1 over x. Now I'm ready to do the derivative. Okay, so I got y prime now. I'm doing a different color. So now it's derivative time. Drop it like it's hot. Bring it down. That's negative 1x to what power? Negative 2. So again, subtract 1 to that guy. Negative 1 is now negative 2. And then I have 7, and then times the derivative of cosine of x. What's the derivative of cosine of x? Negative sine of x. I would simplify that a little bit, right? If I have a negative exponent, shoot that guy down. So my final answer I would have is negative 1 over x squared. And then 7 times negative sine of x, I would write that as negative 7 sine of x. The final answer I would have negative 1 over x squared and then minus 7 sine of x. Okay, so do the derivatives of each one as you go. Last but not least, ladies and gentlemen, example 9 says find the value of the derivative, which again, remember, that's the slope of that tangent line of the function of at the indicated point. So I've given you a function. I've got y equals x plus 3 quantity squared, and I want to find the value at this point. I want to find the value of the derivative. Now, when you hear the word value, I want you to find the value. What are you looking for? What's your final answer going to be? Is it going to have x's in it, or is it going to be a number? It's going to be a number, okay? So that's the thing you got to look for. I'm looking for a number when I'm all done, okay? Well, if I want to find this derivative, if I want to find the slope, we got to go ahead and find the slope of this guy. Any suggestions on how to do that? Any ideas? How do I do the slope? Foil it. Make it easy on yourself. Make it look like a polynomial. Very good. So foil this thing first. So if you need to, write it out. X plus 3 times x plus 3. So I'm just going to rewrite it. So now we should know we get x times x is x squared. 3x and 3x is 6x. And 3 times 3 is 9. Okay? Now I can find the derivative. Right? So let's do the derivative now. So y prime is my derivative of y. And what's the derivative of x squared? 2x. What's the derivative of 6x? 6. What's the derivative of any constant? 0. So that's my derivative. This allows me to find the slope of that tangent line anywhere on my graph. Well, they want you to find what is the slope at this point. Okay, so they're giving us an x value. They're saying, hey, x is 5. Now all we got to do is plug it in, plug it in. So take that, 2x plus 6, and we're going to plug in that 5. Don't need to plug in y. There's nowhere to plug in y because that's y prime. That's different than y. I get 2 times 5 is 10, and then plus 6. So my derivative would be 16. So that would be my slope, that value, that derivative at that x value of 5. Okay, the slope of that graph would be 16 over 1. Okay, that's the value I'd be plugging into my math button. Okay, any questions, y'all? So those people at home, I'm doing number 9. As I take a look, number 9, I've got a little work first. I got this x on the bottom. Let's bring it uptown. So just rewrite the function. I've got negative 5 and then x to the negative third. Now I can do the power rule, right? So now I can do the derivative. Notice I'm switching colors. Okay, the blue one is still the function, just rewritten. So now I can take negative 3 times negative 5, which we know is 15, and now deduct 1. What's negative 3 minus 1? Negative 4. If you leave it like that, I would probably simplify it. Usually I want you to do that. So go ahead and rewrite that. So my final answer, do the Duncan rule. We got 15 over x to the 4th. Final answer.